So welcome to the video lecture on applications of the normal distribution. Previously we were looking at the specific normal distribution with a mean of 0 and a standard deviation of 1. That's called the standard normal distribution, and that one has a random variable denoted with a z. But remember that normal distributions don't have to have a mean of 0 and a standard deviation of 1. Normal distributions with other means and standard deviations are normal, but not the standard normal. And so we denote those with an x. So here's what a sketch looks like. These values down here are the z values. So the mean is at 0. For the standard normal distribution, that would be the mean. The mean would be 0, which would be in the middle. And then we've got 1, 2, and 3 standard deviations on either side. All right. So if it's not a standard normal, then whatever the mean is going to go in the middle at this highest point. And we're going to see 3 standard deviations in either direction. So if we make up an example here where we've got a mean of 25 and a standard deviation of 2, the normal distribution looks like this. The mean is 25, so that goes in the middle. And we've got, we're going up by 2s, up to 3 standard deviations in either direction. Now keep in mind these go out to infinity in both directions in theory. It's just that most of the area under the normal curve is within 3 standard deviations, so that's as far as we draw. All right, and we're going to assume that this represents the distribution of weights of adult beagles. So if we put the z and the x on the same sketch, you see that a mean of 25 lines up to a mean of 0 for z. So an x of 25 is equivalent to a z of 0. An x of 27, that's 1 standard deviation above the mean, is equivalent to a z of 1. Okay, so z actually represents, and this is an important interpretation, z represents the number of standard deviations above or below the mean an observation is. So this 27 is 1 standard deviation above the mean. 23 is 1 standard deviation below the mean, so it has a z of -1, etc. So if we wanted to find a probability associated with x, what we could do is we could convert it to z. We could find out what the z value is, and then find the probability of z using StatCrunch the way we did before. So the question is then, how do we convert from x to z? Well, it's a pretty simple formula. And again, this is an important formula for us. Z equals x, that's the value we want to convert, minus the mean divided by the standard deviation. So let's do, we'll do a couple of examples. Here's the first one. So the first one, we want to find the probability. We're still assuming a mean of 25 and a standard deviation of 2. We want to find the probability that a randomly selected beagle weighs more than 28 pounds. So we've got our sketch here. Here's 28, right between 27 and 29. And you can see that the z-score there is going to be between 1 and 2, so it's going to be 1.5. But let's look at the sketch. So greater than 28 is going to be this blue area here to the right of 28. And you can see that that's going to be equivalent to z being greater than 1.5. But if we plug into the formula, you get z equals 28, that's the value we want to change, minus 25, because that's the mean, divided by the standard deviation of 2. And we get 1.5. And let's use the standard normal distribution. And the way we're going to do that is over here on StatCrunch. I'm going to Stat, Calculators, and I'm going to pull up the normal. And just like we did before, we're going to leave the mean at 0 and the standard deviation at 1. And we want to find the probability that z is greater than 1.5, so just type in greater than 1.5, and we get 0.0668. And that's our answer. Okay, so 0.0668. So again, just to recap, what we did was we took 28, converted it to z, and then we used the standard normal distribution in StatCrunch. So we used a mean of 0 and a standard deviation of 1, and found the probability that z was greater than 1.5. Okay, so that's our first example. I want to point out here that there's another way we could have gotten to the same answer. And I'm going to be extremely picky here. I want you to convert to the standard normal and then find the answer that way. So we can do the answer, we can get to the same answer though by changing the mean. We said it was 25 with a standard deviation of 2. I think, let me go back and look. Yeah, mean of 25 with a standard deviation of 2, and we wanted to find the probability that x was greater than 28. So we'll put 28 in here and compute, and we do get the same answer. And that's a fine way to check your work. It's also fine to do that in MyStatLab. But it's important that you understand the relationship between x and z. And so for that reason, I'm going to insist that you do it the first way on any problems that we work together, on anything to be turned in for a grade. Okay, so here's more information on that. This is just the output. Again, this over here on the left is what I want to see on graded homework and tests. Okay, so a second example. Suppose the high temperatures in June for various years have a normal distribution with a mean of 82 degrees Fahrenheit and a standard deviation of 4. And we want to find the probability that if we randomly select a day in June, the high temperature will be between 75 and 85. So I've gone ahead and sketched this distribution. So the mean is 82, so that goes in the middle, and we're going by 4s in either direction out to 3 standard deviations. So 82 plus 4 is 86, plus 4 is 90, etc. And we're looking for the probability that the high temperature will be between 75, which is right about here, and 85. So we sketched in, we shaded the area between them. So the first thing we're going to do is we're going to take 75 and 85 and convert both of them to z. So we're going to subtract the mean, which is 82 on both of them, and divide the standard deviation, which is 4. So you can see that an x between 75 and 85 is equivalent to finding the z between negative 1.75 and 0.75. So we're going to go to StatCrunch and find, for the standard normal, the area between negative 1.75 and 0.75. So we've got negative, we're looking for between, so negative 1.75 and 0.75. Hit compute, and that tells us that the answer is 0.7333. So that's our answer. So in other words, 73.33% of all June days will have temperatures between 75 and 85 degrees. All right, so that's the first two examples. I'll pick up in the next video with the inverse normal probabilities.